And what that translated to, the absolute value of a number, is how far that number is from 0 on a number line. Given that how far is just a distance, it can't be positive or negative. You say, how far is it from Wetaskiwin to Millet? The answer is 13 kilometers, or whatever it is. You would never say it's negative, even if you were traveling in a south direction, unless this were a physics class and you were talking about vectors. What this translated to is the following, and we're going to be using this idea a lot over the coming days. The absolute value of x is equal to x if x was positive. I would like you to mull that statement over in your head. The absolute value of a thing, in this case the thing is x, is equal to x if that thing is already positive. What is this saying? It's telling you that if you're taking the absolute value of a positive number, you can simply drop the absolute value signs. So, for example, the absolute value of 9 equals 9 because 9 is greater than 0. And when I say 9 is greater than 0, I'm talking about this 9. The thing inside the absolute value sign. Now I'm going to give you the second rule, but before I give you the second rule, I'm going to give you an example of the second rule. The example of the second rule would be the absolute value of negative 11 is equal to 11 because negative 11 is less than 0. So what I'm telling you here, and I know it seems as though I'm going to be all of a sudden making things more complicated for seemingly no reason, but there is a reason. I mean, if I said to you, what is the absolute value of negative 11, I hope you just say it's 11. You don't really think about it too much because you've developed this internal rule probably that says the absolute value of a negative number is found by just lopping off the negative, just making it positive. But the rule is this, and this is going to really have to require that you think deeply about this before you really understand it for some of you. The absolute value of x is negative 1 times x if x is less than 0. What is this saying? It's saying if you want to take the absolute value of something and that thing is negative, then it has to become positive because the absolute value is positive. How do you make something that is negative positive mathematically? We could say, well, you just don't write the negative, but mathematically what you do is you take that thing that's negative inside of the absolute value signs and you multiply it by a negative to make it positive. So the absolute value of a negative thing is negative 1 times that thing. And this is something that we're going to be applying a lot. We will be applying it to absolute value functions. Maybe not today, but maybe a little bit today, a lot tomorrow, and a lot on Thursday and Friday. It becomes a very deep idea. Anyway, does anybody have any questions with any of the problems that were assigned for practice? All right, one last thing before I just say to you, then you can use this class time. You're going to have about 15 or 20, well, about 20 minutes here to work on that assignment. One more thing regarding absolute value. I didn't show this to you yesterday because I want you thinking. I don't want you blindly putting things into your calculator. But you do have an absolute value function button on your calculator. It's just not its button. You won't find it anywhere here. It's really unfortunate because if you have a scientific calculator like you would use in junior high, you'll find a button somewhere on there that has X with the absolute value signs. And when you hit it, it absolute values anything. This one is a little more hidden. At this point in time, I'm not really sure why you would want to use it, but I'm going to show it to you anyway. If you wanted to determine, for example, what the absolute value of negative 11 plus 25 minus 40 was, you know, what I would do without knowing about the button is I would take 11 plus 25 minus 40. I would figure out what that is. And by my count, perhaps you can help me out here, it's negative 26. Okay. So when you simplify what's inside, you get negative 26, which is 26 because we're taking the absolute value of it. On your calculator, if you want to get to the absolute value function, it's under the math area. So you hit the math key. It's under the number sub-menu because we're dealing with numbers, so NUM. And it's the very first thing. So on a TI-83, it looks like this. And, you know, you could enter negative 11 plus 25 minus 40. You don't really need to close the brackets because we're only doing one operation here. If you were then going to add something or multiply the absolute value by something, you would have to close the brackets. Anyway, you get 26. Does it look any different on a TI-84? It does. It actually shows the symbols, yeah. I'll show that to people. Come over here. So on an 84, when you go and choose absolute value, you're actually given the two symbols. If you're in math print, I don't even know if any of you really know what that is. We got time, so might as well have this discussion. I'm not a fan of this calculator because, for example, if I want to take in science 0.5 times some number squared, and then I have to subtract some other number, I just type it in. If you do the same thing here, 0.5 times some number times 8 squared, and I keep typing here and I forget that I have to scroll over to bounce out of that exponent. The other issue I have with this calculator is if there were more numbers, and there are in a lot of the courses I teach, my text wraps around here. So I can see everything that I've entered, right? This becomes a real good thing when you're entering functions in Math 30 because they get very long and they wrap around. But if you do that over here, okay, so scroll out of there, what did I have? Minus 32 plus 68 times 65 divided by, you can see what happens. It scrolls off the screen. And then it's just a preference for me. I don't like having to scroll around to see what I've entered. I'd like to be able to see right here on the right. I would just look up there and I tell my students, particularly in physics, before you hit enter, let's check to make sure you've entered everything correctly. What are you going to do over here on the left? You got to start scrolling around. It's awkward. That's just my take on it. Anyway, that mode that your calculator for, I think most of you have a TI-84 or higher, is called math print mode. And if you ever want to use the features that the 83 has, which means it doesn't wrap around, or it does wrap around rather, so it doesn't scroll off the screen, and you don't have to worry about moving the cursor out of a squared, so it's going to look like this. You go to mode, and way down at the bottom you have a couple of options. One is called math print and one is called classic. So I don't know if any of you use classic. I'm not going to type this in, but if I typed in all that stuff that I did, I don't know if it's still there. It's not. If I type in all that stuff that I did earlier, it will wrap around. I think, though, that if you go math, absolute value, yeah, it doesn't show those lines. Okay. So you lose some features when you go to classic. But I just thought I would let you know. Some of you would benefit from being in the mode this calculator is in now. Forgetting about absolute value. I'm saying I think some of you would benefit from being able to see everything that you've entered before you actually hit equals or enter. Okay? briefly, the assignment that is due, and Sachi, I will get you a copy, and Grace, I will get you a copy. I'll do that right now, actually. You're welcome. So this is due Friday, November 26th. That's this Friday. Is very similar to some of the problems we did in the quadratic equations unit, except instead of me giving you the dimensions of, say, the painting or the dimensions of the background, what I'm giving you is the area. So the first part of this question is very basic, probably for 1 mark. What is the length of the side of the painting? Well, a square has an area of the side length squared. So that would mean you would have to take the square root of the area to get the side length. But I'm asking you to express it as an exact value, which means it will be a radical because none of these numbers that you're given on any of your assignments, and they're all different, none of these numbers are perfect squares. So you have to simplify the radical and express your dimensions in simplest form. Now, the next 2 bullets, which are worth 4 marks, is you have to determine when this thing is centered, what the width of the border is going to be when you mount that picture on top of the background for framing. And since they're both squares, it will have a uniform border all around. The distance, the width of the border at the top, bottom, left, and right will be equal. And you have to come up with an equation using the numbers in the question, an equation relating x to an area. And there's a lot of ways you can do it. You could potentially come up with an equation relating x to the area of 125. You could come up with, a different person could come up with an equation relating x to the area of 80 square inches. Or you could come up with an expression relating x to the area of just the border, which would be the difference between those 2 areas. Or there's potentially even a 4th possibility, but I'm not going to discuss it with you. If you can stumble upon the 4th possibility, your life will be very easy, I think. Anyway, it's open as to how you do that. So remember, when you create the equation, you should be explaining why you're doing what you're doing. So, for example, if I saw in this question root 80 plus 2x somewhere, I want you to explain why you're using root 80 plus 2x. If I saw in this question somebody else did it and they had root 125 minus 2x, I'd want to know why they're minusing 2x. By the way, if I see in this question somebody working with root 80, they're not going to get full marks because root 80 is not simplified. That's kind of the point of the first bullet. So there are simpler ways, there are more complicated ways for you to determine x. And I'll leave it to you now for the last 10, 15 minutes or so here. You can work on that. You can work on other things. But over the next few days, things are going to get really busy and complicated, gradually, starting a little later today and then tomorrow. So you're not going to have a lot of class time to work on this. Use your time wisely.